So
Yeah, I
the same
started.
thing,
Yeah.
as we are generating more data than ever, so like financial transaction or sensor networks, all the analytics, email and text messages, and all the social media data. Because of that, we need to, even we are getting more data from automation or internet and user generated content, everything. So it's like every time we are getting data itself. So these are the different areas we most of the applications are looking out for Hadoop kind of thing. Marketing analysis, product recommendations, demand forecasting, and fraud detection. We will be using more and more for them. So, and there are two problems right now. That is, one would be large-scale data storage and also analysis. Once the storage has been done, moving forward, analyze that particular data and get the useful insights for the company to make sure that to make the decision on that particular data. Say, for example, if I'm getting some, um, my data is already there. I want to make sure that from the data I want useful insight for me. Say, take the example of IBM itself, and it want to look across what all the different tools it is working across and what all the projects it is getting far more results on. So we can give that data and then find out internally we can able to analyze the data, even the big data, even terabytes of data. With historical data, we can able to proceed with that data. We can able to find the trends of the market, or else what is the trend of this particular company, or in that way everything we can able to know from the data. Earlier, they are able to store the large amounts of data, but cannot able to analyze that particular data in terms of taking the decisions kind of thing in days, or it will be taking days to find some of the results for them in earlier. But now it was become very much faster that even in near real time everything is getting possible with the help of Hadoop and all the big data applications. So disk capacity, it was like, you can see that disk transfer rates also increasing randomly, but not to an extent where the data is increasing. It's up to some speed, but not to the highest of its capacity compared with the data which is increasing at a random pace. So data access is one of the bottleneck.
Mhm.
So accessing would be the slow one. So say for example, if I'm reading a single 3 terabyte disk, take more almostly 4 hours for me to read across a 3 terabyte disk, only for reading, not for analyzing with a single disk. So with the distributed system and also data localization with the help of Hadoop, we can able to find and read the data even more faster and able to analyze the data in minutes and able to give the solution on top of it. So typically, some of the common modern distributed systems would be, we can able to say them, it is MPI, PVM, and Condor are the frameworks which would be working on the large scale processing. So they might have the powerful compute nodes, separate systems for the data storage, and fast network connection to connect them. But the main difference is that they cannot, they will have the powerful compute nodes, in the sense powerful master nodes they will have, and all the data storage will be in the separate machines. So the resources are being wasted, like all the storage systems or the slave RAM capacity and all the systems are we are wasting it. So only we are using it for data storage in normal, like any of the other large scale processing distributed systems. So it would be in this fashion. So first we'll be copying the data from the storage to the compute node and then perform necessary processing, and then we'll be copying the output data back to the storage. This is how first we'll get the data and then analyze that and get the processing, and then again we'll be putting back that storage. So this will be working fine with very small amounts of data, but comparing that with large amounts of data, it will be getting worse, as compute node will be the bottleneck for us. So these are all the complexities: availability, data consistency, event synchronization and bandwidth limitations, partial failures, or any of the cascading failures. So these are all the complexities which involves in a distributed system. So in normally system requirements for, so we'll look across some of the solutions for that. So take the example of failure handling. At any point of time, we are able to, there will be failures in our system if we are using any of the distributed system. So systems are tend to fail. So normally failure handling properties for any of the ideal distributed system would be automatic, transparent, and graceful, which would be able to recover, and everything should be happening without manual intervention. So these are all some of the properties which we we will be seeing across we want to see in ideal distributed systems. So, and also regarding to that, linear and all some of the more system requirements would be linear horizontal scalability. So this I have explained it, virtual scaling versus horizontal scaling. So horizontal scaling, we can able to add a number of nodes and able to load and also properly load the capacity, and we can able to get the results with the help of say for example, if I'm having virtual machine of 256 gig of RAM, that I can able to achieve with some 100 nodes with 2 GB itself, with minimum components. With a reasonable cost, I can able to handle such kind of requirements. So the other more thing is job should be running in isolation. So one job should not affect any of the other jobs. So somehow, if we want, we can able to put dependency on one job to other, but all the jobs should be running in isolation without any dependency from one another. So this is how, when all the jobs should be running across concurrently, so performance can be affected by other jobs in normal distributed systems. So all of these requirements can be addressed in Hadoop. So it can have linear scalability, and also all the jobs will be running in relatively isolation, and everything will be independent of another job. And it's simple programming model, and all of them are automatic, or it's automatic and transparent across and graceful, transparent, and it is far most recoverable. All the data can be consistent with the help of CRC checks every data. whenever we are copying our data, there is a cycle redundancy check when before sending it to, when we are sending data, we'll be sending up a CRC check also. When once the data nodes receive that data, it will, once all the data has been copied, then it will check on with the CRC check to make sure that data is consistent across, or else if the CRC check doesn't match, it will discard the data and re-follow all the other steps to fetch the data from the client. So these are all Hadoop. It's a traditional distributed computing system. So it's radically different approach. It was inspired from Google GFS and MapReduce architecture. So what all the topics or problems which we have discussed earlier, all of them will be addressed using Hadoop. It's high performance storage systems. So Hadoop aims for linear horizontal scalability. So with cross communication among nodes is minimal. So cross communication in the sense uh, one to one. So all of them will be in cluster. So say for example, if I'm having 10 node cluster, so one to one to every node, say first node to 10th node, any of the node, everything will be Hadoop combining the 10 machines will be taken as a one machine itself.
Okay.
So you can able to query on top of it. If you are writing any of the Hadoop command in any of the 10 nodes or else from the edge nodes, you will be getting result which is there in all the 10 nodes combined. It will not be it will not come as an individual feature.
Yeah. Okay.
So every of the nodes will be cross communicating between. So it will able to get the details and everything. So that's the main reason whenever we are starting our Hadoop cluster, we should be mainly firstly starting up with passwordless SSH between all the nodes of the cluster, so that Hadoop will be able to log into that machine and get the data from there without any authentication required from them. So we need to add extra nodes itself to increase our cluster capacity and also the performance. So earlier, whenever we are adding up the nodes, it was mainly for the storage itself. So we are adding storage capacity itself in earlier distributed system. But here, when we are in Hadoop, when we are adding any of the extra nodes, we are increasing the cluster capacity and also the performance because we are adding the extra CPU time also to the cluster. So whenever we are adding a new node, we are adding the storage as well as the compute stability. That means the RAM ability or else the computation power to the cluster. So as I told, it's based upon commodity hardware itself. It is the other term for that would be industry standard. So clusters are built across with on the standard all industry standard hardware. So you can able to find for any of these machines, you can able to use with basic machines also. So for the data access bottleneck, the solution is like, so the main thing for data access is like network access is very much costly in any of the cluster. So separate storage and compute systems will be creating any of the bottlenecks. So because we are using the most of the network resources at that point of time. To store and process the data in the same machines is one of the main uh, solution to make sure that we can use less network access or less networks time. So this is why whenever in Hadoop there is concept called data localization. So whenever we are putting the data, so first it will be moved on to a particular node, and then there will be a replication across onto the cluster. Two other nodes will be replicated across. So at the point of time, if at any point of time, if my node is failing, then other two nodes will have data present. So in that case, it can able to handle the topic of fault tolerance that and high availability concepts. Hello, Tushara?
Yeah, I'm here. Yeah.
Yeah. Do you able to get my points?
Yeah.
Are you understanding it?
Yeah. Yeah.
Any problem in between?
Mm,
So if you don't understand in between, please let me know so that I will
yeah.
go on to the topic and will explain you even more deeper in that case.
Yeah. So far, it's okay. Yeah. I will ask you, as I said yesterday, I will ask you questions later because I have to go through the
Okay, okay,
session again, the recorded session again tomorrow because yesterday and today I didn't get much time for going through that again.
okay.
So
That's not
there
an
is no
issue.
school here, so you can imagine how it will be.
No problem.
Yes.
So Hadoop is a large-scale data processing system. So these are the two components which you need to remember that Hadoop provide two main components to achieve this, which would be for data storage, it is called HDFS, which would be naming as Hadoop Distributed File System.
Yeah.
And for data processing, we'll be using MapReduce.
Okay.
So
Yeah.
these are the
While
two.
I was so the certifications you mentioned, I have seen the website called MAPR. I was just going through the Hadoop notes before.
Mapper is one of the distribution. Yeah.
So I read about the online certification and all those things there. So
So every distributions have its own kind of training or
okay,
the certification module for it. Cloudera, you can able to find certification, and also for Hortonworks certified, Apache Hadoop developer, or Apache Hadoop administrator. These are all the trainings and they will also train for that particular administrator, and then we'll be giving the certificate on top of it.
yeah.
So these are the two components. Whenever we are considering Hadoop, these are the two main components coming into picture. HDFS is the heart of Hadoop, which is the file system, Hadoop file system, and MapReduce is on top of it. So all the computation, just like heart of them will be the data storage, will be HDFS, and all the brain, that means all the computation and everything will be taken care by MapReduce.
Okay.
So these are the main components for Hadoop.
Okay.
So job scheduling and others main components are file system utilities and job scheduling and monitoring
Monitoring.
and the web UI. So you can able to access and look across the cluster from the UI itself.
Okay.
So from browser you can able to find what all the uh, what all the files present across in your cluster.
Okay.
Otherwise, in any of the system, you need to go into that machine, physically log in onto that machine, and then provide all the list of the commands, list of the files which are available in in that particular location.
Yeah.
So
Instead of that, we have
that
the user
yeah,
interface, another user
web
interface.
interface to access that.
Okay.
As an admin, we will have
Access to that other.
and access to the Linux
Yeah.
commands, so we can able to go there, or else based upon our availability and our flexibility, we can go on to the browser or else to the cluster
So
directly on it.
so the job scheduling, you as you said, so in here also there will be some certain set of jobs will be running, and we can monitor
Yep.
those things through this web
Job
UI.
scheduling and monitoring is nothing but, so whenever I trigger a map reduce job, all of them, so I'll go with the components. So HDFS will have its own daemon process running across, and for MapReduce there will be two daemon process running across. So they will be taking care of everything. So
So all
I'll be
those things we
using,
can check through the UI, right?
yes,
And if it is, if we need to do some custom scripting or anything, we can go to the, we do have the Linux, the server side access as an admin.
custom scripts and all the things. You have to write your own MapReduce job, or else if you want to write it in paid, you
No,
can write
we
it out.
normally do some Linux, see in the normal Linux or Unix server side, if we
So,
need to do something, we do it from the server side, right? Customize
yeah.
script or something for something like a cron or something like that. So
Yep.
do we have the
Customize it
same
in the
system
sense
here?
that
Same.
the thing is that whenever we are using as an admin, so we'll be writing our custom scripts on top of Linux. Okay, on top of Linux, we will be writing our customized scripts.
Yeah, that's
That
right.
means uh, shell, or else the kernel, Linux kernel will able to understand shell language. But in Hadoop, it is the main thing is Hadoop has been written in Java. So even every Hadoop, whenever we are running a Hadoop instance, it is nothing but a JVM running across Java virtual machine which will be running. So that's the main reason whenever you are installing Hadoop, you should be having Java installed on your machine. So point number one, so whenever it's on top of Java virtual machine, so whatever the language which you are writing it across, it internally will be converting that into Java objects, because JVM will only take the Java objects itself, right? So it will convert everything. We should convert everything as Java objects, and then it will consume that. So Java, it will run on top of JVM, all the Java objects.
Okay.
So if I want to write any of my custom scripts or custom jobs for my thing, I can able to write my own MapReduce job, whether it can be in Java or else in any of Pig or Hive, or else using any other languages, C++ or even Perl scripting or anything. Then we can able to one. There are connectors for different languages. Say for example Perl, you can write your own MapReduce job from using Java, or else using Perl scripting or Python. Even R programming, you can able to write your MapReduce programming in there. So whatever we are running on top of Hadoop, it is a MapReduce job. So if I want to run any of the result sets on top of Hadoop HDFS, it will be mainly MapReduce job.
Okay.
So that's why these are all the two hardcore main components which will be running on top of Hadoop. So there are many related tools which will be integrated with Hadoop. So for data analysis, Hive and Pig are the data integration tool, data analysis tools. As I said in my in yesterday's session, I've gone through the
Yeah,
one
the
of the
guys.
slide for this, right?
Yes. Yeah.
Yeah. So for machine learning, Mahout is the tool, and database integration, it's Scoop,
It's good.
which is from RDBMS to Hadoop, and workflow management and all the scheduling and everything. It will. So the one main thing is scheduling the job internally between all the nodes of the MapReduce will be taken care by the MapReduce daemon itself. But monitoring on top of it if I want to monitor my nodes and if I want to monitor the jobs, so or else I want to schedule my jobs, I will be using Oozie as my workflow management.
Okay.
And for cluster management, it's Cloudera Manager. So for Cloudera, we'll be using Cloudera Manager. If I'm going for Hortonworks, it will be Ambari. So Hortonworks implemented its own monitoring tool, Ambari. So they will in Hortonworks it will be called as sandboxes. Everything sandbox will be the term which they will be using. So these are not considered as core Hadoop. Core Hadoop means these two, HDFS and MapReduce combined will be called as core Hadoop. So these are all the Hadoop ecosystems, not core Hadoop. They are part of Hadoop. Hadoop is a framework. Considering Hadoop as a framework, MapReduce and HDFS are core part of Hadoop, and all of the other things are just the Hadoop ecosystems.
Okay. Just the related tools, as it mentioned there.
Yeah, all
We
of
are
them
using these
are,
tools to work on Hadoop, basically.
yes, yes. If I write, say for example, if I'm writing a Hive query, okay, if I'm writing select in the Hive command prompt, if I'm writing some select queries to run on top of that particular table, it internally will convert that into a Java program and then it will be running on top of Hadoop. So it internally will trigger a MapReduce job itself. That's why we have in earlier slide I have mentioned that it is on top of MapReduce. First is it is HDFS, then MapReduce, then on top of it we are having different tools like Hive, Pig, or else Mahout, and Oozie, everything on top of MapReduce itself. So whenever I write a Hive program or Pig program or any of the Mahout machine learning program, it will be internally converting that and will be running on top of the MapReduce. It will be triggering a MapReduce job itself.
Okay.
We'll see that practically in tomorrow's session. So why it is going, what is happening when we are writing any of the queries or any of things. We'll see that in tomorrow's session.
Okay.
Today I'll
So,
be sharing you some video sessions. Sorry, not video. I'll sharing you some material and also the VM so that you need to download VMware Workstation.
okay.
Please make a note of it. VMware Workstation is the thing which you need to install in your machine. So once you install that, I'll be sharing you that VM. So you need to download that VM and it will be across 2 to 3 GB of the file. You need to download it and then unzip and you can able to use that VM.
So, VMware workstation. So I can do it. You will
So
be
I'll
sharing it.
show VMware Workstation. You can get it like VMware Workstation Player. You will be finding it.
Okay.
So this is how it will be looking like. So if in that I will be going and opening a new file. So that particular file, when I unzipped that particular VM which I've shared, which I will be sharing you, you have to unzip it. And once you go to that location, you will find all the supported files. You click on them and open means it will start up as free. It will be working as a new VM itself, just like the training VM.
Okay.
So it if I click on play virtual machine, it will start it up as a VMware VM state.
So if I go to VMware workstation, if I will get it online.
Yep, it will be just like another machine running on top of your. So
No, no,
you
no.
can,
How can I download it? That's what I'm asking.
yes, you can get it online.
Okay.
VMware Workstation Player. You are able to see this, right?
Yeah, I saw.
VMware Workstation Player. This is, if you have to make it like, you have to take it as a personal use itself, non-commercial use. If you are downloading it as a personal use, it is free for you.
Workstation player, right?
Yes,
Free product
VMware Work.
downloads under the free product
Yes,
downloads.
yes.
Okay. 64-bit. Okay.
So did you install that?
Yeah, it's coming. It's downloading.
Okay, okay, no issues.
Do I need to select enhanced keyboard driver? No.
No need of those
Okay.
things. Okay. Just 1 minute, I'm giving you the presentation permissions. Can you show me that?
No, I have clicked on that. Yeah, it's installing VMware Workstation. Can see that, right?
Yeah, yeah. So tomorrow, post this session, I'll be sharing you all the material and also the VM. Please download it, and tomorrow we'll install it, and also we'll try to see all the HDFS concepts.
Okay.
So what all the features, so how it all the different replications and architecture of HDFS and everything. We'll see in tomorrow's session. So any questions from your end?
No, so far it's so. You can see my screen, right?
Yes. So it's only for commercial, it's not commercial, so you have to give your any of your email ID. Yeah. So in that, whenever I'll be,
Oh,
so
you did it?
if I want,
Okay.
so whenever you are, once I share that zip, so you can unzip that and put it somewhere on desktop itself. And from open window, you can go to that open, whatever the location which is there in desktop. You can go to that and click on that VM file. Then it will open like that, just like I showed you, Hadoop training
Oh,
VM.
okay.
So
Okay.
then you can click on that and it will start up, play that virtual machine. It will start up across.
So using that, I
So
can you can help me with the installation and stuff.
yep. Tomorrow I'll be once I share it, you please download it, and tomorrow we'll see that on. First we'll work on the installation, and then we'll go for
Okay.
it. Yep. Sure.
That's it for today.
Yep, that's it for today. First 2-3 sessions will be basics, and so once
Yeah, even that is
you
good
start
because
with,
yeah.
you should be accustomed to this particular class session. So initially 1-2 days will be to make sure that you are to question up you.